Hi, it's Rob. Welcome to this last video in the Cumulus Cycles Kubernetes playlist. Thus far, we've been creating our Kubernetes resources individually by executing kubectl apply for each pod and service. However, this isn't very efficient. So in this video, we'll look at deploying our resources using Kubernetes deployments. A deployment provides for declarative updates for pods and replica sets. And replica sets are used to ensure a specific number of pod replicas are running at one time. So if you want 2 pods for your web server and app servers, there would be a replica set created to spin up and manage those multiple pod instances. So in a deployment, you declare a desired state, and Kubernetes deployment controllers change the actual state to match the desired state. For example, here's a deployment for an Nginx server. And actually, it will spin up 3 Nginx servers or 3 Nginx pods because the spec has a replicas value set to 3, with the container coming from the Nginx 1.14.2 image. In our application, we can create deployments for our web server, app server, and database server, and which will declare a desired state of the deployment, and Kubernetes will handle provisioning the resources for us, and that's what we'll do now. However, before writing the code, I'll jump into a terminal and do a kubectl get all to show that we currently don't have any resources deployed for our application. To get started, in this new k8s deployments folder, I'll create a new file named webserverdeployment.yaml, and I'll start out by specifying the API version, which in this case will be apps/v1. The kind will be a deployment, and for metadata, I'll give it a name of web server deployment. Inside of the spec, I'll specify replica's value of 1, which will create the replica set with 1 replica of the web server pod. The next property I need to specify is the selector with a match labels which specifies the app of web server. This web server will match the name in the template that we specify for the web server pod. And the template comes next. So here, we want to specify the metadata and the spec for the web server pod. So I'll copy this code from the web server pod spec and paste it into the deployment. Now, if I were to jump into a terminal and kubectl apply the web server deployment, it would spin up 1 instance or 1 replica of this web server pod. However, we know that we also need the web server service to expose the web server. So instead of spinning up the web server service using the current spec, I'll add this to the web server deployment as well because the web server is dependent upon the service. So to do that, in the deployment file, I'll jump down, add 3 dashes as a separator, and then copy the contents of the web server service and paste it into the deployment definition and save the file. Now if I jump back into the terminal and kubectl apply the web server deployment, we'll see the deployment has been created. And if we do a kubectl get all, we'll see the web server service in the web server pod. Now I'll go ahead and create a file for the app server deployment. This too will have an API version of apps v1. It's a deployment, and for metadata, we'll give it a name of app server deployment. The spec will specify replicas of 1 with a match label selector of app server. And for the template, we'll copy the contents from the app server pod spec and paste it in. Then we'll add the separator and grab the contents of the app server service spec. Copy that, paste it in, and jump back to the terminal and apply the app server deployment. And here we see the app server deployment and the app server pod. Now, finally, we'll jump back to VS Code and create a deployment for the Mongo database. The API version and kind will be the same. The metadata will have a name of Mongo deployment. Again, there'll be 1 replica with a match labels app of Mongo. For the template, we'll still jump into the pod spec and copy the metadata, the spec, which will specify the container and the ports, the volume mounts, the environment variables, and the volume. And we'll add the service. Save the file, jump back in the terminal, but instead of doing a kubectl apply on the Mongo deployment, I'm going to do a kubectl delete all to delete all our resources. I'll do a kubectl get all to verify the resources have been deleted. And now I'll do a kubectl apply -f and give it the path to the current folder, which will execute all the templates in the current folder. And if we do a kubectl get all, we see our resources are running. So now if I jump into a browser and go to localhost 30,080, we see our application running with our data from the database. So that concludes this video on Kubernetes deployments. If you found any of the videos in this series useful, feel free to give them a like. And if you'd like to be notified when I release new content, please consider subscribing to the channel. Thanks for watching.